Chapter 7 is about understanding the relationship between different trigonometric ratios. We're going to be looking at sections 7.1 and 7.2 today, and then later in the week 7.3 and 7.4, and then we'll have a small quiz. What is a trigonometric identity? A trigonometric identity is essentially just a rule that is true for all values that you plug in. So, looking at this equation, x plus 3 equals 4. This is only true when x equals 1. But if I come over here and look at this equation, x plus 3x equals 4x, well, this equation is true no matter what I plug in for x. And that's the difference really between an equation and an identity. So you guys have seen identities before, and an identity could be something as simple as factoring identities. X minus y times x plus y is equal to x squared minus y squared. We'll be looking at trigonometric expressions that are identities. So some of the identities that we already know are the relationship between the sine, cosine, and tangent, and their reciprocal functions. So the sine is the reciprocal of the cosecant, or 1 over the cosecant. And of course that makes the 1 over the cosecant equal to the sine. Then you've got the tangent, which is 1 over the cotangent, the cosine, which is 1 over the secant, making the secant 1 over the cosine, and so on and so forth. And then, of course, if the sine is opposite over hypotenuse and the cosine is adjacent over hypotenuse, then the sine over the cosine is going to give us the tangent, the opposite over the adjacent. So now we've got this other identity, which is known as a quotient identity. If the sine over the cosine is the tangent, then if I take the reciprocal of that, that would be the cosine divided by sine. That would, of course, give me the cotangent. So one of the things that trigonometric identities can be helpful for is if we know one value of ratios, we can use that to find other values of ratios. So let's take a look at a problem like this. The secant of theta is equal to 3/2. I know that 1 over the secant is equal to the cosine. So 1 over 3/2 is going to be equal to the cosine. And 1 over 3/2 is 2/3. And so I can find out that the cosine of theta is 2/3. Now there's a whole other set of identities known as the Pythagorean identities. And the Pythagorean identities are named after the relationship from which they are derived, namely the Pythagorean theorem. So we all know the Pythagorean theorem. We take the square of two sides of a triangle, and that's equal to the square of the hypotenuse. In the triangle inside the unit circle, we get x squared plus y squared equals 1. But we also learned that in a unit circle, the relationship between x and y was that the x value was the cosine of the angle created here, and the y value was the sine of the angle created at the origin. And if we make these two replacements, one here and one here, then we get this. And this is the sort of quintessential Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. And there are other Pythagorean identities, but essentially they all follow from this one. So this is the only one you really have to memorize or kind of know automatically. Cosine squared theta plus sine squared theta equals 1. Now what can you do with this identity? Well, first of all, you can come up with two other identities. Now, the other Pythagorean identities all start with cosine squared theta plus sine squared theta equals 1. So I've got these two here. Now, on the left-hand side, we're going to divide everything by cosine squared theta. Well, that's supposed to be a square. All right, cosine squared theta. When you divide everything by cosine squared theta, automatically this term is going to turn into a 1. So this term becomes 1. Sine squared theta over cosine squared theta becomes the tangent if I apply the quotient identity. And 1 over cosine squared theta becomes secant squared theta if I apply the reciprocal identity. So this is Pythagorean identity number 2. 1 plus tangent squared theta equals secant squared theta. Now if I come over here and this time instead of dividing by cosine squared theta, I aim to eliminate this term, I'll end up dividing both sides by sine squared theta, sine squared theta. This turns into 1. Cosine squared theta over sine squared theta, I'm going to use a quotient identity here, and I'm going to get cotangent squared theta. Sine squared theta over sine squared theta, of course, just gives me 1. And 1 over secant squared theta gives me cosecant squared theta using the reciprocal identity. And this, of course, is Pythagorean identity number 3. So there are 3 Pythagorean identities. We always start with the most basic, which is cosine squared theta plus sine squared theta equals 1. And then we can derive the other two either by dividing by sine squared theta, or over here by dividing by cosine squared theta. So now I can use these Pythagorean identities again to help me find other values that I might not know. So here's an example. I've got sine theta equals 3/5 and I'm being asked to find the tangent. So right away I've got the Pythagorean identity, which is going to give me sine squared theta plus cosine squared theta equals 1. Since I know the sine, I can go ahead and plug that in over here and make a substitution. So I'm going to plug in sine theta equals 3/5. And now I need to solve for the cosine. So of course I'm going to turn this into 9/25 and subtract it from both sides. I get cosine squared theta equals 16/25 and cosine squared theta equals plus or minus 4/5. Now here I have the cosine and here I have the sine. I know that the tangent is equal to the sine of theta over the cosine of theta. So now that I have the sine and the cosine, I can solve for the tangent. So notice over here that I'm using a quotient identity. I plug in for the sine of theta. I plug in for the cosine of theta. And there I have it. I've solved for the tangent. Okay, so we know that we can make substitutions to help us find one value for another. Sometimes there's a bigger picture that we want to see. We want to work with an equation or something a little larger than just one term at a time. And so we need to know how to simplify expressions. So when you're simplifying an expression, it's important to know what an expression is. Okay, an expression is not it's not an equation. Okay, there's no equal sign. So there's only so many things that we can do. Okay, you can't do to one side what you do to the other because there are no sides. There's no equal sign. So when we're simplifying, we can only do one of 3 things. We can apply a known rule. Okay, generally these are like our trigonometric identities or our equivalencies, like sine equals 1 over cosecant. We can add 0, or we can multiply by 1. Generally, this comes in the form of multiplying by a over a, where I want to multiply by the same thing on the top and bottom. So here are my identities that I can use to simplify expressions, right? We've got the reciprocal identities, we know those, and we've got our quotient identities, right? Check. And then we've got our three Pythagorean identities. Check. So let's take a look at an example where we simplify an expression. So notice that there's no equal sign here. So what can I do with this guy? Well, right away I might notice that this term and this term both have a common term. So right away I might notice that I can factor out sine x. This leaves me with sine x equals 1 plus cotangent squared x. Okay. Now I'm going to notice, hopefully, that this is part of a Pythagorean identity. 1 plus cotangent squared x is going to be, let's see, that's going to be equal to the cosecant squared x. Okay, so now I can make a substitution, and I get sine x times cosecant squared x. This is sine x times 1 over sine squared x. And now I just cancel one of these, and I get 1 over sine x. And the reciprocal of the sine of x is the cosecant of x. And I'm done. So the last thing that we want to look at today is something called verifying trigonometric identities. So how do you verify a trigonometric identity? You essentially want to show that two sides are equal to each other by showing that they're the exact same thing. So I've got an equation, it's got a right side and a left side. I want to work one side until it's equal to the other side. How do you verify trigonometric identities? There's no one exact perfect way to do it. So two people can do it different ways and still do it correctly. When you verify a trigonometric identity, it's not about getting a right answer, it's about demonstrating a correct process. So some of the steps you can do is you can make substitutions, you can factor, you can multiply, you can rewrite things in terms of the sine or cosine or make substitutions. And all of these things will help you simplify one side to get it to look like the other side. So I'm going to show you an example here. One thing that's really important to remember that these are not equations, even though there's an equal sign. So we want to essentially work one side to simplify it and simplify it and simplify it until they're equal. And again, we got to go back to what are the rules here. We can apply the known rules. Those are going to be our what do we know? Okay, the trigonometric identities that we do know that are known rules. We can add 0, or we can multiply by 1. And again, that's probably going to be in the form of a over a, or an equal expression over an equal expression. Okay, so we're going to transform one side into the other. And let's take a look at this one. Now here I've got 1 plus tangent squared x over cosecant x secant x equals tangent x. I've got one side that's very complicated and one side that's very simple. So I'm probably going to work this guy, the more complicated side, until he equals the less complicated side. And my goal is to get the two sides to be the same. So the first thing I'm going to do is I'm going to replace 1 plus tangent squared x with secant squared x. That was one of my Pythagorean identities. Then I'm going to cancel one of these secants with this secant. And that leaves me with secant squared x over cosecant squared x. Secant is equal to 1 over the cosine. Cosecant is equal to 1 over the sine. And when I simplify, I get tangent x equals tangent x. You know you're done when the right side equals the left side. So today